All right, well, welcome. In this video, we're going to be looking at our second type of conic section, and that's dealing with an ellipse. And so if you look at that visual here, basically an ellipse is when if you were to make a slice in our conic at a slight angle, you might think of this shape as an oval shape, but another name for an oval is an ellipse. Now this is the next slide here gives us the technical term for what an ellipse is. And if you want, go ahead and read that, but again, it's just a bunch of mumbo jumbo. It'll help when we look at an actual example, and which will be more of a visual, which I'll show you in the next slide. Now, if you notice at the bottom, it says, watch this. I highly recommend on my Schoology page on our website, make sure you watch the video that I have on there for the application. What it is it's a video from a TV show called This Old House. And the nice thing is it's not a couple of math teachers talking about ellipses, it's actual construction workers talking about how they use different tools to be able to create an ellipse. And it's something, if we had time in class, that would be something that we would do. So I highly recommend watching that video just so that way you have a visual and see an application of how you'd use this in the real world if you ever get into construction. All right, but these are the shapes. So ellipses can have a couple things. It can have either what we call a horizontal major axis or a vertical major axis, meaning it'd be stretched horizontally or stretched vertically. And we do have some key points. So two of which would be our vertices. I'm not going to write that out, but you have your vertices on either end. And then you have the foci. The foci, just like your parabola, is inside the ellipse. And then this also has a center. And then this would be your, what we call our major axis or focal axis. If it's vertically, we would have a vertical major axis. So what I'll do is I'll abbreviate. So this would be a horizontal major axis. This we'll call a vertical major axis. Or if you want to be lazy like me, you could just abbreviate it HMA or VMA. But for your notes purposes, you might want to just pause the video and just write down that that refers to horizontal major axis and vertical major axis. Another phrase that we use in place of major axis is focal axis. So again, you can use either one. The reason why they call it the focal axis is that's where your foci would be found on, is on that axis. Because we do have a minor axis, that would be the other axis that would either run vertically or horizontally. All right, let's look at this table. So this gives us the form, the standard equation that we're going to be using to represent our ellipses. Now it's important to see this piece here. When you're looking at our denominator, the a term is always the bigger denominator. So if that bigger denominator is under the x, we're going to have a horizontal major axis. If that bigger denominator is under the y, we're going to have a vertical major axis. That's what this is saying in the second row. And then we have our foci. So now let's think about the foci and the vertices for a second. Go back to this previous slide. So if you notice, the vertices are on the actual line. And when we're looking at an equation, the equation will give us all the points that are on the line. So the a value that we have from our equation, we're going to use that to find our vertices. Now, if it's being affected horizontally, so if it's a horizontal major axis, that means that that a value would impact the horizontal coordinate, the x coordinate. If, looking at that second column, if it's a vertical major axis, then our a value is going to impact our vertical coordinate, our k or our y value. All right, now let's talk about that c value. So our value for c, we get that from, ignore the bell, sorry. We get our value for c from this Pythagorean relationship. Now I do want to point out that our original equation for both of these are plus, but when we find our Pythagorean relationship, it's not a squared plus b squared, like you'd see with the Pythagorean theorem, it's a squared minus b squared. So please make sure that you recognize that difference. That's going to be valuable when we go to look at our next type of conic section, hyperbolas. But for these, it's going to be a squared minus b squared. And so we use that to find our c value. Now that c value, again, we use that to find the foci. And the foci is not on the actual graph, it's inside the graph. So I remember that, so what I keep straight, or how I keep this straight, is the vertices are on the graph, so that uses the A value. The foci is not on the graph, so that's going to use the C value. But again, if it's a horizontal major axis, that foci, or that the C value impacts the H, the horizontal value, or if it's a vertical major axis, that C value impacts the vertical part of the coordinate, the K value. So let's look at an actual example that makes sense of all this. So again, so here we have everything that I just talked about. So we can see that visually on this graph. Sometimes it can be a little cluttered. If you want to pause the video and write this down in your notes, you can. Otherwise, let's just look at an example. All right, so with this one, again, the A value is always the bigger denominator. So here our bigger denominator is 9. Square root of that would be 3. So our B value would be 2. So to find our C, it's going to be A squared minus B squared, because again, it's the opposite of what we have here. So A squared is 9, our B squared is 4, and 9 minus 4 would be 5. So we get C, our C value would be the square root of that. Technically, yes, it would be plus or minus square root of 5, but just for this, I'll just write down square root of 5. All right, so let's find the center. So again, this is going to be, by the way, since that 9 is under the Y value, this is going to be a vertical major axis. That is going to help when we go to find some of these coordinates. But first, the center is just our H and K. So for this, our H is always associated with our X value. So if you see we have X plus 1, so we take the opposite of that, so it'd be negative 1. Our K is associated with our Y value. So Y minus 1, the opposite of that would be a positive 1. So our center is at negative 1, 1. Let's find our vertices next. So again, this is a vertical major axis, so the horizontal is not affected. The K is. And since the vertices are on the graph and we get the points in our graph from our equation, that's where it's related to our A value, not our C value. So our H is negative 1, K value is 1, so we plus or minus 3. We don't leave it like that though, we write this as two separate coordinates. It'd be negative 1 is our X, and then 1 plus 3 is 4, and then 1 minus 3 would be negative 2. So those would be our two coordinates for our vertices. For your foci, again, this is going to be a vertical major axis, so it's going to be the K that's impacted by our C value, so it'll be K plus or minus C. So for that, be negative 1, and then 1 plus or minus the square root of 5. That would be your foci. So that's it. Pretty simple. So why don't you guys try this next one completely on your own. Again, look to see where your biggest denominator is. That'll help us see if it's a vertical major axis or horizontal major axis. So why don't you guys go ahead and pause this video, try this one on your own, and hit play when you're ready to check your answer. All right, let's see how you did. So this one you should recognize that, again, the A value, the bigger denominator, is under the Y. So this is going to be a vertical major axis again, and so our A value would be the square root of 16, which is 4. Our B value would be 2. And we can find our C value again. Now this one, if you stopped and you just said square root of 12, technically you want to make sure you look to see if that can simplify. So you could use that tree diagram to find the prime factors. Otherwise, you could, if you know the perfect squares, and 4 is a perfect square, and 4 times 3 is 12. So the square root of 4 is 2. So this would simplify to be 2 square root 3. All right, so to find the center, you'd get the opposite of X and the opposite of Y. So that'd be the coordinate 3, 2. The foci, that is not on the graph, so that's going to use our C values. Again, it's a vertical major axis, so the H stays the same, so that stays at 3. But then our K value, we'd have 2 plus or minus 2 square root of 3. By the way, I didn't emphasize this in the previous one, but that we can just leave like that. We can't simplify that any further. So don't take 2 plus 2 and say, well, that's 4 square root of 3. That would be wrong. You cannot add those together because they are not like terms. But for our vertices, we can. So our vertices, it would be 3 and then 2 plus or minus your A value. Our A value is 4. So we would actually simplify that further because 2 plus 4 we can add together and get 6. And 2 minus 4 would be negative 2. So we get the coordinates 3, 6 and 3, negative 2. All right. Well, sometimes we're going to see problems like this, just like what we did with parabolas, where we're going to have to use completing the square. Now the difference for this and parabolas is that with this we do have two squared terms, both an x squared and a y squared. So we're going to keep those together on one side of the equation. So let's start with our x terms. We would have 9x squared minus 18x. Then we're going to add something here eventually. And then let's put our y terms together. So it'll be plus 4y squared plus 8y. Now that minus 23 isn't associated with the x or the y, so we're going to get that to the other side. So I'm going to add 23 to the other side, so that would just be positive 23. All right, so remember, in order to complete the square, we need to have no numbers with the squared term. So we want to make sure that if there's a number in front of the squared term that we get rid of that. So we're going to factor out a 9 for this one. And for the y's, we're going to factor out a positive 4. There's two numbers that we're going to be adding to the 23 this time. All right, so let's start with the completing the square with that first set. So remember, what we're going to do is we're going to take half of b and square it. That's what goes here. So when I take half of b, half of negative 2 is negative 1. When I square negative 1, it becomes a positive 1. I guess I don't need the plus in there. It's already there. I want to see erase. There we go. Okay, so we're going to put 1 there. But the problem is, remember, that is not just a simple 1, because we would distribute the 9 through, so that 1 really has a value of 9 times 1. So that's what we put over, that's what we add to the other side. So that the weight or the value of that 1 is really 9 times 1, or 9. So we're going to do the same thing here. We're going to take half of b and square it. When we do that, half of 2 is 1. 1 squared is still 1. So again, 4 times 1 is 4. That's what we add to the other side. All right, so now, here's what we have. We're going to complete the square on each of these. So again, remember, to complete the square, we take half of whatever b is. We don't square it this time, so half of negative 2 is just negative 1. So in that way, we get the sign correct. Plus 4. The same thing is true here. Half of 2 is 1. So it'll be y plus 1 quantity squared equals. And on the other side, we can add all of these together. And when you do that, you end up getting 36. Because 9 plus 4 is 13, and 23 plus 13 would be 36. Well, we don't want this equal to 36. We want to get this equal to 1. So I'm going to divide everything by 36. So when we do that, we're going to reduce these fractions. So in that first fraction, we can divide both the top and bottom by 9. So that would give us 36 divided by 9 is 4 in the denominator. And then for the next set, we can divide both the top and bottom by 4. 4 divided by 4 is 1. The denominator, 36 divided by 4 is 9. And 36 divided by 36 is 1. Technically, they do ask you to find those, the center, the vertices, and the foci, but we're not going to take the time on that. If you want to do that on your own, you can. I just want to make sure you know how to set up this and get this equation. So why don't you guys go ahead and pause this, or work on this next one. So pause the video and hit play when you're ready to check to see if you can do this on your own. All right, let's see how you did. So you should have gotten a final answer there of x minus 4 quantity squared over 1 plus y plus 8 quantity squared over 4 equaling 1. If you didn't find all those specific pieces, you didn't have to. But if you didn't get that as your answer, pause the video and see if you can figure out where your mistake was. But hopefully now you have a better understanding of how to work and solve ellipses. So good luck now as you work on your assignment.